cells is sodiums and calciums. And inside of our cell, we have potassium and magnesium. So we have our double positives and we have our single positives doing this piece of the dance. But in the real world of our bodies, every single electrolyte would be doing this exchange. So in the body, for the nervous system and the muscular system, or the neuromuscular system, when this was occurring, every single electrolyte would be moving, would be exchanging positions. So if you think about a magnet, what happens if you have, did y'all play with magnets as kids? What happens when you put the two positive ends together? They repel. All right, so within our body, inside the cell, I always I picture this cell as a beautiful home. So inside this beautiful home, that really is a nice round cell, not like we've got it drawn out here. It's this really pretty round cell wall. Y'all please don't fall off the stage. Really, Dr. Ada will come get me if I kill a student. Or you break a leg.
You're retired.
All right, so, like, don't hurt each other. Anyhow, so inside the cell is this nice place. So outside the cell, living in this extracellular fluid environment, are all these other electrolytes. Now, if you lived outside and you had the opportunity to go in, what would you do? You'd go in, right? So inside the body system, we've got all these separate systems at work. So I'm going to give you a for instance, in the cardiac system, what stimulates a heartbeat? What's responsible to start a heartbeat? The SA node. So the sinoatrial node in the atria of the heart is what we call the heart's pacemaker. So that sinoatrial node sends out an electrical impulse. Here's my electrical impulse. All right. When this electrical impulse is sent out, this electrical impulse starts and it goes down and it starts stimulating all of these nerve cells within the heart, the Bachmann bundles in the atria. But as it goes down, this electrical impulse, as it stimulates this cell wall becomes permeable, meaning now this cell wall is open and things can move. So as soon as this cell wall becomes open, these electrolytes go, oh, I can get in. And they immediately move in. So y'all move in. Now when they move in, what's going to happen to the ones that are here? They're repelled, so they move out. All right. Now an interesting thing here, calcium moved in. Now if I had had my thoughts with me, I would have put them in. But calcium can only enter the cell through these little places called calcium channels. I picture them like children's slides sliding into the cell. Calcium channels. So they slide into the cell through these little places called calcium channels. We give a class of drugs. Anybody tell me the class of drugs we use that has the word calcium channel in it? Calcium channel blockers. What do you think those do? They block it. Now they don't totally keep calcium from getting in, but they slow it down so much that they make calcium ooze into this cell. And what they do is they slow down the heartbeat and they decrease the blood pressure. Because if calcium can't get in, they slow the heartbeat because they won't let it get in here and make the heartbeat fast. And they also, in the muscle walls of the arteries, they won't let it jump in and tighten up the arteries. So they slow the heartbeat and decrease the blood pressure. All right, just an offside, because that's a drug you're going to be talking about a lot. All right, so now we have depolarization of the cell. Depolarization means the cell is the opposite of what it normally should be, because it should be like that up there. It should be potassium inside and magnesium and all those others, and these things out, but now it is backward. It's depolarized. The poles are the opposite of what they should be. And the cell, inside the cell goes, this is not right. And the little brain inside the cell goes, this is not right. And inside the cell, we have something called the sodium pump. And the sodium pump goes, this is not right. And so the sodium pump starts pushing. And the sodium pump starts pushing out the things that don't go. And what happens is the pump starts pushing out the people that don't belong. The other things that belong come back.
So sodium, potassium,
This is it.
and then it pushes the potassium back in.
No.
No, it doesn't.
It pushes the sodium out.
Okay.
And again, the people that belong move back in.
Okay.
So it pushes, right. As it pushes that stuff out, this stuff comes back in. Y'all, this is very simple explanation. It's a lot more complex than this, but y'all, you don't have to do that complex. Just keep this in mind, all right? So now, what's the normal heart rate?
60 to 100.
Right? Okay, so now y'all are gonna dance, and I'm just gonna be electrical impulse, right? Boom. Get it, I'm the sodium pump. Pump, 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 pump. Boom. Pump, 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 pump. Boom. Pump, 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 pump. Boom.
Hold up your little signs.
Pump, pump, pump. Now I'm going to start doing it 100 times a minute.
Yo,
Y'all see them dance
hold up
that
your
fast?
signs.
No, we don't want to dance that fast.
Have y'all got the visual good enough? Have y'all got the visual good enough? Y'all got it? All right. Y'all can drop it.